Sega. Hello everyone, good morning, good afternoon, good evening. Welcome to another video. Today I am going to my eye component, my virtual eye component, which basically does the following. Let me show here. So I have here my player, which shoots when clicking and also walks, crouch, yada yada. And that's the enemy there. And the thing I'm gonna show today is the eye component that I made for it. So basically, if I get into its eyesight, it sees me and shoots at me, right? So, it killed me. So if I just appear, you see it shoots at me. If I come here, shoots, I hide. But if I come too close to this gap here, it sees my feet and kills me. I'm gonna show it again, but now with the debug mode on. Debug visible collision shapes. So now you can see all the raycasts in the game. There is one here that see comes from the face. So basically it's showing what it's seeing. This area here is whenever I get into this area, he will see me, basically, he will be able to see me. And so, and this dot is this just for debug purposes, so it kind of like points at the last point where he saw me. So he spotted me at here, the last. That's why his weapon is pointing at that direction. So see. And if I come close here, it saw that if I actually aimed for my feet and killed me. This is not gonna be a in-depth tutorial or not even a tutorial per se. I think it's gonna be basically me going through how I designed this component. It's nothing that I came up with. So I basically watched this video here from, let me show you. So this video from GD Quest, basically the easy way to make enemies seize in Godot. If you go there, you have a better explanation of the many methods. Basically, I use the sweeping method that I explain around here. You go there, you're gonna see pieces of code that's really similar to what I've made. Without further ado, I'm gonna show you my code. Okay, so let me go to my structure first, the component. So the component that I created, I wanted something reusable that gives any enemy the ability to see. So in my case here is going to be a shooter. So every enemy has a head and has eyes on its head and also have a weapon. So the shooting mechanism is decoupled from the seeing mechanism. So I created a component called virtual eyes, which is basically this, which has the view range, which is a big circle. So anything that comes inside the view range will trigger the ability to see. Will trigger this element, this component, and then it will calculate if whoever owns this component is actually able to see the player. The LOS is the line of sight, so it's basically a raycast here, which is manipulated by the code to see, oh, am I able to see you? Where am I able to see you? And the looking at point is this little dot here in the middle. This has no real use in the game. It's just for debugging purposes. So if you're doing this, if you want to do this or not, it's up to you. I have the code there. I'll show you where I update this. Basically, it moves this orange point around to see what is the point that's being sent to the parent component I saw the player there. All right. So let me walk through my code, and I'm also gonna explain why I made the changes that I made. All right, so let me, I will show you the enemy. So the enemy here, you can see, has basically the basic sprite, the head, the weapon. The weapon is actually, the gun here is a separate component as well that can shoot. And here's the virtualize. So in a broad sense, the virtualize has an event, player on site, player not on site, and basically just gives a point, and the enemy code takes that point and passes to the weapon, which shoots at that point. I'm not going to go through this in this video. It's not the purpose of the video. Just so you understand how I chose to structure my characters. I go here to the player, blah, blah, blah. The player has anything to do it. So test level. Let's show you the code. That's what I want to show. So I go here for my virtualize and open the code for you. So this is the code. Let's see if I can zoom in here so it's easier to see. I'm gonna walk through the main points of the code. So the view angle here is basically the cone of vision. I think if you go to the GD Quest video, he calls this a cone of vision. Is the angle where to which the player can see you. All right, so I'll bring up a screen here so you can actually see. Give a quick explanation on what everything is. So the cone of vision, think like this. This is the origin of the eye component, and the cone of vision is basically, let's say there's a cone, and if a player is here, that's the sweeping area where it's gonna cast the ray to identify the player that entered the area of the component. The view distance is, once I cast the ray, it has this distance to actually spot the person. So you have let me erase this. So you have the area there that triggers the component, the eye, the virtual eye, and then they have the raycast, right? This allows me, like, once I got here inside this area, I trigger the eye, but once the eye is doing the raycast actually can go for 1,000 pixels. The way it is right now, I don't think that's actually going to go to 1,000. It's probably because once I walk out of this spot, it will stop triggering this code, so it won't apply the 1,000. But you could make changes to this code. So, once you're spotted, you're only gonna the enemy will only stop seeing you if you actually hide behind a block or something, or if you go further than the 1,000 pixels. Okay, so it's almost like here he can hear you, and once he hears you, he spots you, but once he spots you, you have to go further than this to hide. But this is actually not implemented in my code right now. I'm just telling you, so if you want to expand to do more of that shenanigans, that's kind of the code that you would use. So all right, so let me, I can actually move this. I'll move this here so we can see the code and the whiteboard. So yeah, the view distance, the scan step, that's something that I added in the GD Quest video. He uses angle, so the steps of the scan is by angle. So it's 5 degrees, so every 5 degrees it scans. I didn't want this because if I have a small thing here and it's further away enough, if I'm doing the sweeps by angle, I can actually jump that. If it's kind of like, that's 5 degrees and that's 10 degrees, but the point that I actually inside the view is in between, is at 7 degrees. So if I do by angle, I can miss that. So what I did is my scan step is by pixels. So it doesn't matter how further the the object is, the thing will move based by pixels, so 5 pixels by 5 pixels. So that's ensures that even if I increase the size of the area, the viewing area there, if I increase that, it's not going to increase the granularity of my steps, if you know what I mean. Probably early optimization that won't be too necessary, but I did that. So just explaining, not saying that my code is great, but that's the reason that I create that, just so I ensure that it is based by pixels, not by angles. So you go down here, you have the main area of code. So I'm getting my view range, and then I'm checking inside the view range, get overlapping bodies. So is there anybody here that is a player? So my component player actually has a class name, so I can do this filter function in the get overlapping bodies. So that's handy. So if you want your eyes to see other type of things, you could see, oh, I don't know, I have a turret that is actually a player's turret, and the turret sees enemies. So you could update this code here to see like, oh, if your body is enemy, right? So here, if body is on range is more than 1, is more than 0, it means that something entered that range, and then the code starts, the main part of the code. So what it does is it gets the spotted body, right? If in our case the player gets the player, gets the line of sight here. I just isolating it from the reference into a variable here. I do this just to keep the typing. I know that maybe I don't need to do that, but because I use Visual Studio, I found that this works better for me. Anyway, so here I'm changing, so angle step based on amount of pixels per step. So as I said, I'm not doing, the steps that I'm doing are not by angle. So here's the angle here. So I'm not, for example, I'm not going 5 degrees by 5 degrees. I'm going 5 pixels by 5 pixels. But because my view distance can change, it's actually supported here by 1000. I don't know how much this angle has to be. So I do a little math here. So arctangent of the steps divided by the view distance. So that's just like some trigonometry there. And that gets me the actual, okay, for 1000, so a view distance of 1000 and a step of 5 pixels, the angle has to be that, right? So that's basically calculating the angle. So basically at this point here forward is gonna be really similar to the GDQuest code. So I am incrementing it in base of angles now. And the steps quantity, I just dividing the view angle, which is the cone of vision, by the angle steps that I found here. So if it's like 100 of view angle and the steps per angle is 10, so I'm gonna have 10 steps, yada yada. And here I'm adjusting my angle to spotted body. So let me use here the whiteboard. So I have my components like this, right? I have the component, and that's the line of sight that I'm using here. And once the component, a player walks in here, so the player is here, and the spotted body is this guy, right? Now I need to change the line of sight to be pointing at it. So I getting in this line the angle to that spotted body with this code. So line of sight, global position, point dot angle to point, and I pass the spotted body global position. So the starting angle is this angle, which is the angle to the spotted body, right? And now I have here the player spotted at variable, which will be filled or not. So here is a code that's heavily based on the code in the tutorial by GDQuest. And I made some changes, but basically let's go over all it. It basically goes, it has this part here that checks if the current step is odd or even. And then it calculates which angle I'm checking, right? Which takes the odd or even, and so based on that says -1 or 1 times the size of the step times the I here that is the step. I'll come back to this in a second, right? And then I take the line of sight, I change the target position based on that. So view distance times I create a vector basically on the angle and the angle to check, the starting angle plus the angle to check. So in the whiteboard now again. So if my start angle is this and my angle to check is potato, I'm basically adding potato to that. And now I have the new position for the line of sight. Okay. And then I force Raycast update. So I update during the physics process where the line of sight is. And then I check for collisions. Again, if line of sight is colliding, if the collider is a player, I get the point. Okay. And once I get the point, here I'm updating that looking at point, that debugging orange point that starts at the center. So I update, so if the player was here, it basically gets updated to the new position. And then you can see in the game you have debug mode on, where was the point that the player got spotted. And once it gets that, I change the player spotted at to that variable. I break the loop. And if the player was spotted, I emit, oh, the player was spotted here. And if it wasn't spotted, I say player not on sight here and also outside of the body on view range. That is, so if the enemy is shooting at me because I got spotted, it keeps shooting at you. But once you out of sight, the enemy knows, oh, I don't see that guy anymore, so I'll stop shooting, right? So I'm going to talk now about the differences in this code with the GDQuest code, which is really small, but it just to fit my game mechanics, right? So to the whiteboard here, I'll bring this in the middle. The original code for GDQuest, what it did is basically it made the sweep. So the for loop there made a sweep, and the sweep was based like this. You had the line of sight, the raycast, and the loop would move the raycast up to the end of the cone of vision, and every iteration it would check if the enemy is in any of those points. Okay, so I actually had my code exactly like this in the beginning, but what would happen is if I had here, I'll create my enemy here. My enemy was here, right? And he had his weapon there, and I was here. No, this color is a bit odd. I'm a good guy and I'm green for some reason. So I was here, right? It would create an oddity that like the enemy saw me, but he would always aim at the tip of my head, which is maybe we could say that, oh, he's aiming for your head, but always aim for the tip of your head. Or if you were behind a wall here, like this, you'd aim for right here, right? So most of the shots would get here. And that is because the sweeping motion is from top to bottom, right? So whenever you found, and the first thing it finds would register as, oh, I saw you there. So I didn't want that behavior because it was just odd to be always like just aiming at the tip of your head. I wanted more something like you aim for the middle of your body. So if the player was here, you'd aim at the middle, or the closest thing to the middle that he can see. And that's why I move here, then I'm back to the code here. That's why I created this thing here that checks if it's odd. So if it's odd, you would do -1, else would do 1, and that multiplying for the angle plus the step times the step. That made so my sweeping would work slightly different. So I'll erase here. So my sweeping, I think you guys figured out already. So that's the cone of vision. My sweeping would start at the middle and then do 1 step above, 1 step below, 1 step above, 1 step below, above, below, and so forth. So if the enemy was spot here, it would most likely, let's see, if the player was spot there, was most likely in the middle of the body. And if there was a block here, it would either shoot at the head or the foot, whichever he saw first during the sweeping back and forth here. And that's it. I think that's the things that I want to go through. And again, this is not a tutorial. If you want to actually learn about those techniques and even better techniques, you have to go here. You can go here into the GD Quest video and take a look. It talks at nice optimization points, which I didn't implement, and other techniques, because I don't think all games need to have a complex line of sight algorithm. Like mine, I adapted to my case, and you should adapt yours to your case. So I would recommend taking a look at his videos and seeing what you can take from that and adapt to your game, as I did for mine. So that's why I say mine is not a tutorial, it's just showing my implementation, and maybe you can get some ideas from that. Okay, so what did you think? Is there anything else that you would change on my code? Is there anything in my code that you see that doesn't make sense? Which I think there's a lot of things here, because I have to review a lot of things, like stuff that doesn't work as you'd expect. Like I said, the view distance here is probably locked by the view range of the Area2D or the view range, and other small bits and bobs. Like I think my for loop here, because I'm doing this is odd thing, it's probably giving weird steps. But the thing is, for now it's working for the game, so I moved on. But I'll probably would come back here at a time in the future and review that. All right, without further ado, I will finish this video here because I think I blabbed for too long already. So thanks for watching. Leave a comment below if you enjoyed the video, or leave a comment saying something that would change or some weird thing that you spotted in my code or my process. Thank you as always, and have a nice day.